What is the number of alicyclic structural isomers of C5H10? A3, B4, C5 or D6? For this question, I'm going to start by drawing different structural isomers of C5H10. And then we're going to look at which ones are acyclic. So here is our first one where we've got a double bond, we've got 5 carbons and 10 hydrogens, but we could have the double bond at different points in this carbon chain, which I'm going to draw now. So we can also have it as like a side chain coming off, or we can just have a normal methyl group as a side chain and then the double bond in the longer chain. And finally, we could have it like this with the double bond at the end and a side chain. So these are the ones with a double bond. Now if we look at ones without a double bond, we need to make them cyclic because otherwise we won't be able to have 10 hydrogens. So our first one is going to be cyclopentane, which is quite familiar, hopefully, from your A-level studies. Then we can have cyclobutane with a side chain, or cyclopropane with 2 side chains. But these 2 side chains could be at different points on the triangle, as shown here. And then we could have an ethyl group coming on the top or from any corner, but it would be the same. Then we need to look at which ones are acyclic. So alicyclic is when you have an all-carbon ring. And this carbon ring can be saturated or unsaturated, but it needs to be a carbon ring and it needs to be all carbon. So looking at these structural isomers we have, the only all-carbon rings are these 5 at the bottom. So these 5 are saturated because they are all alkanes and there are no double bonds. So there are 5 of them, so the answer for this question is going to be C. And to get the mark for this question, you need to write C in the answer box provided.